Hello, my name is Steve Einen, and this is a presentation on connecting with SkySpark. But first, a little about me. Um, I'm a lifelong full-stack developer, and I've been developing Phantom for about 12 years now, and of that, been developing in SkySpark for about 10. And now I run a SkySpark support company. We have a small team of tech nerds, and all day, every day, we make dashboards, extensions, and connectors. So why talk on connectors today? I mean, they sound simple, but creating well-designed, robust, and secure connectors is actually a lot harder than most managers appreciate. I mean, if you've got like 10,000 points on an overloaded server that's experiencing network lag, and you're trying to develop automatic authentication failover so you don't lose any data, well, that takes a bit of time and experience to get right. Over the years, we've had a lot of clients, so we think we now have a lot of experience. And we thought it'd be nice to pass on some design tips to help the community out. Some of these are going to be obvious, maybe hopefully some not so. To customize and enhance SkySpark, you generally use the Axon scripting language. And this is pretty much true for anything in SkySpark, except for connectors. Connectors you generally have to drop down to the Phantom programming language. And this is because SkySpark itself is written in Phantom. So to do any sort of like low level and dirty IO stuff, then you have to drop to Phantom yourself to program in. Except until now. Phantom Factory have a product out there available on StackUp called EasyCon. And what EasyCon does is that it lets you create your own connectors using the Axon scripting language. So if you do have any Axon developers out there, go grab them because this talk may be interesting to them too. In this talk, I'll be covering the following topics. I've listed them out here, so 1, you know what great stuff is lined up, and 2, you also know when this presentation is about to finish. For the benefit of any new developers over there, first, a quick recap on what connectors are. Now, SkySpark performs analytics on time series history data. An example of this will be a temperature sensor in a room, and that's going to collect the temperature of the room, say every 5 minutes for every week of every month. Then at the end of the month, we can see what the minimum temperature was, the maximum temperature was, or maybe just the average temperature, and all this other cool analytics that SkySpark enables us to do. But before we can do any of that, we first have to acquire this data, and that's what connectors do. Hi. In my eyes, there are two types of connectors. There are ones where your sensor connects directly to SkySpark. And for these types of devices, it's all about the communications protocol, be it BACnet or Modbus or any of the usual standards that you have in your building. Now, these connectors are all built into SkySpark. So why would you need to create your own connector? Well, maybe you have a legacy device, or maybe you have a device that talks a weird protocol or adheres to an obscure standard. For these connectors can only really be done with a low-level I/O access, and for that you're typically going to need Phantom. The other type of connector then are the ones with indirect connectivity, i.e. if your sensor connects to the cloud and it uploads its sensor data every 5 minutes to the cloud. SkySpark then also connects to the cloud and downloads your 5 minute sensor data from there. Now, the main protocol for talking to the cloud and servers on the web is HTTP. So you might think, cool, that means I just need the one HTTP connector, right? Wrong. Unfortunately, it's not just about communications protocol, it's also about the data. Now, when you're downloading the data from the cloud, it can come in many different formats. It could be JSON, YAML, or XML. And then not only that, this data comes back in lots of different data structures. You can have like nested maps and dicks and arrays of dicks, and your curval could be anywhere in this jumbled mess. Therefore, unfortunately, whenever you have a new device that talks to the cloud, you're probably going to need your own indirect connector. You have to create a new one. But the good news for this is that now you can use Axon to build these kind of connectors. When SkySpark wants a new current value, it hands us the virtual point. Now, the first thing the connector has to do is to work out which physical point this virtual point relates to. May sound simple enough, but in a standard project, you may have, 3 sites with 50 devices each, and on each device you've got like 20 points. So that means your virtual point you've been handed could be any one of, say, 3,000 points on the in the real building. So before we go about, fetching a current value, before we even think about communication protocols or decoding data structures, we first got to work out which one of these 3,000 points our virtual point relates to. And for this, SkySpark gives us an address tag, but it only gives us really the one address tag. And this address tag only has the one value. And in this value, we have to store all the identifying information that we need to identify our physical point. Now, all this ID data is driven by the end system. It dictates what data we need to hold. For instance, if we're working with Danfoss devices, they usually use node, mod, and point values to identify its physical point. Or it may also use rack, circuit, and suction IDs. Note, our address tag can only use simple values like numbers or strings or URIs. We're not allowed to use complicated values such as maps or arrays or DICs, which may be easier to use. So, to get around this limitation, developers tend to just jam all this information together, delimited by a hyphen or a comma or something, and it looks fine, but this is no better than name stuffing. Now, Project Haystack was created to overcome name stuffing, so why now are we going back to the Dark Ages and re-embracing this archaic practice? So my first tip of the day is let's not do name stuffing. Let's instead use a data type with some readability built in. So let's use, say, a URI, because a URI lets us have name value pairs in the query parameter. And that means we can represent our address in the query parameter, so we can easily identify, in the case of Danfoss, what the node and the mod and the point values are, or maybe the rack, the circuit, and the suction values are. And this helps with readability because we only have to glance at a virtual point for us to know what physical point it relates to. And this can really help with troubleshooting down the line when we're trying to work out why connectivity isn't working or why the point is down, because believe me, you will have problems later on, and this helps. We write a lot of unit tests at Phantom Factory, and these are often influenced by behavioral driven design, or BDD. So let me surmise what I've just said as an acceptance test. So, given we need to identify the mapping between a SkySpark virtual point and a real physical point, then when we have multiple key value identifiers, then let's use a human readable means like a URI to encode this address information. And this will help us understand point addressing, which will then in turn help us troubleshoot problems later on. Efficient polling can save on system resources and SkySpark server load. Polling with regards to connectors is just the act of obtaining the current value on a regular basis. But this only happens, or polling is only enabled on a point if that point is in our watch. That is because if nobody's watching the point, and if nobody cares what the current value is, then why should SkySpark bother wasting resources getting the current value in the first place? An easy way to put a point into watch is simply by viewing it in the SkySpark connector app. Or you can use the monitor application in SkySpark to view the point current values in real time. This is a simple plot of a timeline of polling. Now, if no polling interval is configured for a particular point or a connector, then SkySpark will default to 10 seconds. Another way of putting a point into watch is by applying the hisCollectInterval tag to a point. This is something I hope we all know about, but applying the hisCollectInterval tag to a point does two things. One, it puts the point into a watch and initiates the polling process. Independently to that, it also monitors the hisCollectInterval, and when that time elapses, whatever the current value happens to be at that time, SkySpark will then use that value and store it into the Folio database. Now, on our timeline plot here, note the irregular poll times over the very regular hisCollect interval times. This is fairly accurate because, SkySpark defaults to 10 seconds, and if you're on a very overloaded server, SkySpark can't guarantee that exactly 10 seconds on the dot is going to be able to make that poll. All kind of network problems ensue. But as a whole, SkySpark, with its bucket polling mode and everything, does a pretty good job of keeping polls running smoothly and regularly. Here's an example with some real values. Let's say our polling interval is 10 seconds. And why not? That is the SkySpark default after all. And 10 seconds is great for when we're eyeballing, these current values in the Monitor app, because we can see the values update in real time, we know the connector's working well, and everything's great. But it's not so good for resource hogging, because if we have a hisCollect interval of 5 minutes, then for every 30 values, or current values that we've gone and collected, we only save one of those, and the other 29 are just discarded. I mean, well, if we're just watching the 1 point, who cares, man? We could get in one value every 10 seconds. Who cares if we use it or not? But if we're scaling up to 100 points or, thousands or even 50,000 points, then that's a lot of network overhead and a lot of resource processing that's just wasted. So if you have an overloaded server, it's very important to tune your points with tuning records. Conversely, you don't want to set your polling interval to be too slow either. Because if your polling interval is like longer than your hisCollect interval, then you're just going to end up saving the same values to Folio twice. And that's just a waste of the database storage. So what kind of ratio between polling interval to hisCollect interval should we be using? Well, maths dictates that to ensure that our current value is always fresh and stored at once, then we should have a polling interval to be about half of that of our hisCollect interval. Summing up then, given we know the hisCollect interval, then when we set a polling interval, then we should set it to about half of the hisCollect interval. As an example, we wrote a carbon intensity connector for the UK's national electricity grid, and there we set a default polling interval of 2.5 minutes, because the data itself only updated every 5 minutes. An inefficient connector can impact network system performance dramatically, so optimize and speed up your connector by reducing network and I/O calls. For a connector, managing 200 points is quite a modest amount, and when SkySpark wants new current values for 200 points, it will pass to the connector 200 for virtual points and say go. The connector was not unreasonable then for it to take the first point, make a connection to the cloud server, retrieve the current value and save it to the historian, then gets the next point, makes a connection to the cloud server, retrieves the current value and stores it to the historian, gets the next point, connects to the cloud, and so on. It'll do this about 200 times, and that's fine, it works mostly. Computers are really good, at all this processing. But doing this process seems laborious if we're going to do it 200 times. So how can we make it faster? Now, if I talk to developers, they'll often tell me that they've been researching scientific journals and they'll quote at me, big O notation and the best way to optimize loops to make them more efficient. So they're saying, yeah, man, we can optimize the code, we can make it way more efficient. But I'm like, meh, not interested. And they're like, what? I'm like, no, man. If you ask me, what I want to do is I want to reduce the number of I/O and network calls made by the connector. And here's why. Latency is the time taken to do a round trip of request response, I/O type stuff. Now, numbers have been published on average latency times, and these vary from, or these are about RAM caching to disk reads and network processing. And they've been published to give us developers a sense of perspective, because these numbers, depending on what we're doing, are vastly different. Now I'm going to have a quick demonstration of a website that shows these numbers changing over a 20-year period. So here are those numbers changing over a 20-year period. As you can see, as you might expect, as time goes on, all the numbers get less and less and less as computers speed up and speed up. But note the two numbers that don't change here, there at the bottom. They're to do with network overhead. So my takeaways from this is 1. Even bad unoptimized code gets faster over time. Thank you, Moore's Law. And 2, network calls are exponentially slower than anything else. So if I want to optimize my connector, the best way is to reduce the number of network calls. So if we were to synchronize 200 current values, and let's say we have a modest polling time of around 30 seconds, that gives us about 150 milliseconds per current value. 150 milliseconds, well, that does seem a long time. As we saw, it is the same amount of time as the latency of an international network call. But what if there are network issues? What if our request response takes longer than 150 milliseconds? What if the server is under heavy load? And this is not just the SkySpark server, which we have control over, but we could be the cloud server that we have no control over. Maybe that's got a lot of incoming network traffic. Or what if we were to reduce our polling time down to 10 seconds? I mean, obviously, as we just saw, the best way to increase the efficiency of our connector is to reduce our I/O. Our I/O. But how do we do this? Well, here, the REST API is your friend. Usually, we do not have to make an individual call for every single current value to the end cloud server. The REST API usually gives us a way to return all the current values that are available for one device. So let's say if our 200 points were spread across 15 devices, that means we only need to make 15 connections to the cloud server. And that will reduce our overall overhead from 30 seconds down to just 2 seconds. And hell, if we're lucky, the REST API may even give us a way to return all the current values all at once. That's great. Okay, yes, so these fewer calls to the cloud server does result in more data being transferred back to us and more data we have to process then. But hell, as we've just seen, that is nothing compared to the overhead of actually making separate request responses to the server. So, given our connector is using the SkySpark default bucket polling mode, then when we ask to return current values, then we should batch up the current values to make fewer network calls. And this will significantly speed up the time taken to return or fetch our remote data. For example, like our Katera Cloud Connector and our Belimo Cloud Connector both batch up their current values by device ID. And our Pelican Connector, well, that batches up current values by object type. Okay, so Phantom did creep into this talk after all, because this topic is advanced and is for Phantom developers only, and is an extension of the last topic. When we make a HTTP request to the cloud server, then we have to open up a connection with the cloud server. And this opening up a connection is a very expensive network operation. So this tip is simple. Once we have a connection, let's keep it open and reuse it and just transfer all our data back and forth over the one connection. Going back to the last topic and us talking about having 15 devices, well, now we only need to open up the one connection and we transfer the data for the 15 devices over the one connection. This now effectively makes our connector 15 times faster. Ta-da! Well, this tip is kind of Phantom only because Axon generally does not give you this level of control over your HTTP connections. And yes, admittedly, to actually develop Keep Alive connections, it is a lot more code and a lot more effort, but it can be really worth it for a highly contentious connector. Now, here at Phantom Factory, we do have a slight advantage on this because we've developed our own internal HTTP client library. And this client library has HTTP Keep Alive connections built into it. And obviously we use this for all the connectors we make for our customers. So, given a cloud server utilizes Keep Alive connections, then when you open up a connection to that server, then let's keep it alive. For an example, our ChargePoint electric vehicle charging connector uses Keep Alive connections. We also implemented it for our Pelican Cloud connector too, but it turns out that their server will only hold connections open for 5 seconds, therefore making this tip of limited use for Pelican. But hey, at least we tried. So shh, can you keep a secret? Keep passwords safe in SkySpark Secure Store. In Axon, this is not always so straightforward. So here's how. And given Phantom Factory are Cyber Essential certified, it would be remiss of me not to mention this. But why? To protect sensitive data, of course. And indeed, building data is sensitive data. For example, we made a connector that measured the flow of sewage from an entire university campus. And holy cow, is that a lot of poop. Man, nobody needs to see those flow values. Here is some Axon code that makes a HTTP request. And as is standard, it's using a username and password for its authentication. We are also using Phantom Factory's HTTP client to make the request. And why not? It's great, we made it, and I make no apologies for using it. But here is the no-no. The password is stored in the Axon code in plain text. This is a no-no because this means anyone with access to the Axon function, or anyone who can read the Folio database, usually has access to our password. Now, how can we avoid this? Well, we could encrypt the entire Axon function using Axon Encryptor. This would work. This would obfuscate and encrypt the Axon function, therefore rendering the password unreadable. But if the password were to expire, or if it were to change or anything like that, we would then need to re-encrypt our Axon function. So this isn't such a convenient solution after all. Here's another idea. How about we store our password in Folio, just on a record? And now in our Axon function, as you can see here, we do not store the password, so the password is no longer in the Axon function. But it is still in the Folio record, and Folio records are stored as plain text. Anyone with access to Folio can now read and have access to our password. So still, this is not a great idea. The solution here is to use the SkySpark Secure Store. As the name suggests, it is a secure means to both save and retrieve sensitive information. Axon can be used to store information into the secure store, but we need to use Phantom to retrieve information from the secure store, and this is done for security purposes. But never fear, Phantom Factory's HTTP client has got a workaround. So to do this, we use the standard Axon function for storing data into the secure store. This is the password set function. But please, please, please do this in an Axon shell. Don't put this into your Axon function, because otherwise we're just storing your password in plain text again. So once it is in the secure store, we can then use one of HTTP client's many authentication mechanisms to retrieve that password from the secure store and use it in our HTTP request. So here in this example, we are setting the X password HTTP header using information stored in the secure store. And this enables us to use the SkySpark Secure Store to store and use our sensitive information and passwords when making HTTP requests. So given we have credentials for a HTTP server or REST API, then when we need to keep those passwords safe, then we need to keep that password in the project's secure store. And the obvious benefit is this improves SkySpark data security and access. And this feature, well, because it's in HTTP client, it's used by many of our customers. Authentication schemes like JWT, OAuth2, and Bearer, they all involve temporary authentication credentials with a token. So what is a token? Well, After you've authenticated with a website using a username and password, as we saw just now, the web server will often return to us a string value, and this is your token. And then on subsequent requests, when we're communicating with a cloud server, we don't send up our username and password again. No. We just send up our little token. And this is very much like using a cookie on normal websites. And the benefit of using a token is that it means we don't have to send up our sensitive username and password on each request. A big difference between a token and our username and password is that a token will have a limited lifespan. Username passwords usually hang around for the longest time, or they don't change very often. But a token will have a limited lifespan, like it will expire after an hour, a day, or a month. So if we want to use a token, well, here's some example Axon code or pseudocode that shows us how we can use it. We grab hold of the token, we check to see if it has expired. If it has, we use the username and password to get a new token again. And then we use the token to make our normal HTTP request. The problem here, though, is that tokens can be revoked at any given time, either manually by a peer or automatically by the end cloud server for whatever whim or reason it feels like. The issue here is that our code does not renew the token unless it has expired. So if our code is revoked for any particular reason, then we're not going to get a new token until the end of the day. That means from the time it's revoked till the end of the day, we can't get any data. So we now have data loss. And it's easy to forget that because we never truly know if our token is invalid or not. Given we don't know if our token is going to be valid or not, well, let's plan for it being invalid. So here I've just wrapped up our HTTP request in a simple try catch. So if the server does complain that a token is invalid, well, then we have an opportunity to go fetch a new token using our username and password again. Then we use this new token to replay the same HTTP request. This means that regardless of what happens, we can still keep retrieving our data and we don't incur any data loss. It's just a failsafe for those little obscure events that actually do happen. For example, whilst I was writing this presentation in my hotel room, I had a power cut for several hours. I mean, these little things are not supposed to happen, but they do happen. Given we are authenticating with bearer tokens, then when we are writing the request logic, then plan for failure and invalid tokens. This helps us avoid data loss. As an example, our connector for the Also Energy cloud platform used a form of OAuth 2 authentication and bearer tokens. This is a design pattern that I advocate, and it makes testing easier. Thorough testing will reduce errors, reduce developer support time, and reduce user frustration, and I can't stress enough how important testing practices are. Agile development practices advocate that code which is easily testable is by nature better designed. Now, logically, I know this to be true because it means the inputs are more easily abstracted and the outputs well defined. So how can we apply this principle to connector code? We split our code up into two layers. We have a top layer, which is the SkySpark connector integration. And this is doing things like decoding your point address tags, like we saw in the very first topic. Things like batching up our requirements for retrieving the current values. Things like servicing the learn functionality. Then we have a second layer, which is for the HTTP communications only. This is doing things like retrieving our current values or getting the history data or managing our authentication tokens. It's important to have this comms layer because this comms layer is actually easily tested. And we do this by recording samples of real responses sent to us by the cloud server. Now, when we have these responses, that means during the test, we can replay these real requests back to the test. So the comms layer thinks it's talking to the cloud layer, but it's not. It's actually talking to a test that is just returning the canned responses that we recorded previously. And this helps us test and the whole comms layer. So given we are creating a HTTP connector, then when we are designing the functions, then we should split out the communications code so it can be more easily tested. And the benefit is obviously happy customers. To talk about a bit about a fantastic piece of work we did, we built a connector for the PowerFlex cloud platform. Now, due to IP whitelisting restrictions, we didn't have a test account for PowerFlex. Hell, we couldn't even contact the cloud server. It wouldn't entertain that. So instead, we got our customer to record some real HTTP request responses for us. Things like, failed authentications, successful authentications, failed data responses, successful data responses, and such forth. And using these sample HTTP request responses, we then built a test around it, and then we coded the connector to pass the tests. And lo and behold, when we delivered the connector, it worked first time, and that is almost unheard of for software development. And to my knowledge, the connector is still working and running today. You're building a new connector. You've read the specification from the web. It looks good, looks easy, man. So what are you missing? What could possibly go wrong? Probably one of these. SkySpark handles time zones really well. In fact, a little too well. And it's often easy to forget that they are actually difficult. So difficult, in fact, other REST APIs just ignore them and won't accept time zones at all. Other REST APIs, to get around the issue, will only work with UTC time zones, forcing you to convert all your time zones to and from UTC. Also beware when receiving date times from servers. Now, the ISO 8601 is the international specification for the datetime syntax or format. And if you read the specification, like what I have obviously, then you'll know it is a very large specification and it allows any aspect of the datetime to be optional. Whereas ISO parsing in SkySpark requires a complete datetime. Nothing can be optional, not even the seconds or the milliseconds. But it's no biggie, it just means that when we're parsing datetimes, just be sure to use the to-locale pattern parsing instead. Given not all REST APIs gracefully handle time zones, then when communicating with such REST APIs, then beware. And this just helps us avoid incorrect data. As a quick example, the Pelican Cloud, well, they return datetime in ISO format, but with optional seconds. Standards are great. It's just a shame there are so many of them, and not everyone adheres to them either. I mean, Project Haystack has got a standard for units, temperature, pressure, electricity, flow, and all that normal stuff. In fact, they're so common, it's easy to forget that there's a standard for units at all, until that is some random API returns you data in some oddball unit, and you end up looking at your number going, what does this value mean? Case in point, we created a universal connector for Belimo, and everything was going great until they decided to return to us data in a British thermal unit. Now, that is not a Haystack standard. So given not everyone agrees on standard units, when working with some unusual units, then just manually convert them to something Project Haystack understands. And this avoids dodgy and incorrect data. Finally, avoid data overload. Just because data exists does not mean it needs to exist in SkySpark, for not all data is useful or needed. As an example, we've written some SOAP connectors for APIs such as HashFS and PowerFlex. And given we're connecting to a SOAP API, they have many operations that return to us all sorts of data. But we resisted the temptation to bring it all in and instead just concentrated on the bits of data that we needed. Okay, and now I want everyone to take a deep breath. Because it is the end. A couple of keynotes to remember. Junior polling, reduce system resources and server load. Reduce your I/O, significantly speed up the time taken to fetch remote data. And keep your secrets secret, protect your sensitive data. Plan for failure, test more, keep customers happy. If you have any further questions, then you can reach me on any of these channels. I am Steve Einan of Phantom Factory. Thank you for watching.